Okay, so but for your step, so it'll be a step. So what you're doing is the first one is going to start with an open circle. Uh-oh. It's okay. Make sure my ringer off. Hold on. Okay. So you would go from, you have an open circle and then you have a closed circle and you connect it. And then the next step has an open circle, a closed circle, connect. Open circle, closed circle, connect. It's just like that. Open circle, closed circle, connect. It looks like a staircase. Open circle. I'm gonna just do a couple more. I kind of like drawing these. Okay, that's what the graph looks like. It looks like a staircase. Your domain is all real numbers, but your range is only integers, is only whole numbers. So I'm just gonna say integers. So your Y value will only be whole numbers. Okay, so again, that's what it looks like. I just wanted to add that to your pink sheet. We're not going to do rationals because we're actually going to spend a whole unit on that because that graph has a lot. A lot. So we're going to spend the rest of this class period a couple of different ways. I want to do piecewise functions, and I want to give you guys a chance to ask questions. I did move back the due date for 2 of the homework assignments. So just check Canvas because I can't remember. So, alrighty, so let's take out your graph paper and let's graph a piecewise. Oops. So I'll give you a second to copy this down. So we're graphing, this is called a piecewise because we're actually graphing 2 different functions. And this is where understanding the characteristics of each of these graphs on your pink sheet will come into play here. So what this is saying is we have 2 different functions. The first function is linear, but that's only when x is less than or equal to 1. And then when x is greater than 1, it's an absolute value. And it's just a parent for the absolute value. So I'll give you a second to get that copy down and then we'll work through it together. Okay, so let's go ahead and graph this first one. So the first one is a line. I'm gonna graph this one in red. So the first thing first is I am gonna make a table. But for my x values, I have to be very specific. Number 1, I have to start it with 1. So 1 is going to be the first x value I use. Actually, I'm going to make the table a little bit different because okay. So I'm going to start with 1. And then I need to pick numbers that are less than 1. Now for a linear function though, you only need 2 points. So I really just need to pick one number less than 1, but just because I'm explaining it for the first time, I'm gonna pick a couple numbers less than 1. So any numbers less than 1, keeping in mind that our x-axis only goes to -10. So what number should we use? I need numbers. So looking at the number line, let's look at the graph, look at the screen. Notice that I have my point, I'm pointing at the 1, and then I'm only picking numbers to the left of 1. So let's just pick 2 more numbers. I heard 0. 0 is always a good one. And maybe one more. -2. Okay. All right, so let's go ahead and type or substitute those in. So we're going to take 2 times 1 plus 1. And then we're going to do 2 times 0 plus 1. And then we're going to do 2 times -2 plus 1. So go ahead and figure out what you get for those 3 numbers. So 2 times 1 is 2. 2 plus 1 is 3. 2 times 0 is 0. 0 plus 1 is 1. 2 times -2 is -4. -4 plus 1 is -3. All right, is that correct? Is that what you all got? Okay. So notice that it says that this first point, it is equal to. Okay, so because it's equal to, this very first point is going to be closed. Now, the points after it are always closed, but it's that first point that you have to be sure about. So let's go ahead and graph these 3 points. So let's put a point at 1, 3. So 1, 3, put a point at 0, 1, put a point. And at -2, -3, put a point. So this graph is a ray. It's only going to the left. Because remember, we're not graphing all of 2x plus 1. We're only graphing a piece of it. That's why it's called a piecewise function. We're only graphing the piece that is less than 1. Okay, so now we're ready to graph the second piece. This is our second piece, which is an absolute value. Now this one says that x is, oh wait a minute, I did that completely wrong. Was anybody gonna say something? That is completely wrong, y'all. Completely wrong. What's wrong with that? We gotta scratch this whole thing, erase everything. Because what does this say right here? X is what? Greater than 1. And we did less than 1. Girl, ladies and gentlemen, what are we doing here? Y'all just listening to me like I know what I'm talking about? That don't mean nothing. It's first thing in the morning on a Monday. We got to scratch the whole thing. Let's start over, y'all. So we still starting at 1, except we're picking numbers greater than 1. So what numbers greater than 1 should we use? Because we can't use 0 and we can't use -2 because those numbers are less than 1. Let's use 2 and 3. Let's do it. Let's keep it simple. All right, so let's plug it in. 2 times 1 plus 1. You can tell we have extra time. Because usually I'm stressed out, but we were supposed to test Wednesday, but we just moved it back. And we can't move it to Thursday because Thursday is Career Speaker Day. So we just have a lot of extra time to review. So we're still good. All right, so now go ahead and figure out these numbers. take 2 times 1 plus 1, which we already know that that one is 3. That's not going to change. And then you have 2 times 2 plus 1, which is 5. 2 times 3 plus 1 is 7. All right, so now, because this graph is going to the right, so 1 up 3, 2 up 5, and 3 up 7. Okay. Okay, so now let's do our second graph. And the second graph is an absolute value. So the second graph says that x has to be less than 1. Now, this is what I want to make sure you understand. Even though this is not equal to 1, you still have to graph that point, except it's an open point. Okay, so you still need to start your x values at 1. So we're still going to start it at 1. Even though it's not included, we still have to include it in our table. Now let's pick numbers less than 1. So let's do 0. Let's do -2. So this function says take the absolute value. So you're taking the absolute value of 1. Then you're going to take the absolute value of 0. And then you're going to take the absolute value of -2. Okay, so what's the absolute value of 1? Just 1. What about the absolute value of 0? And what about the absolute value of -2? 2, +2. So go ahead and plot these 3 points. Now the first point, and only the first point, is going to be an open circle. So when I plot that point at 1, 1, that's an open circle. So see how you can tell that I didn't fill that point in? Because remember, it has to be a function. If this was a closed point, that would mean that at x equals 1, then we had 2 different y values. That's not a function. So one of these points has to be open. So we have an open circle here. Now everything else, though, is closed. It's just this first number that's not included. So then we have a closed circle, and then at -2 we have a closed circle. Now if you need to look at your pink sheet, remember an absolute value looks like the letter V. So what we have is we're going to go down, and then it just goes straight up. And you can graph more points if you need to. Yes. It's a piece of the graph. Okay, we did a piece. This is called piecewise functions. So maybe you want to label this, if you want to title it. These are called piecewise graphs. Because it's not the whole graph, it's a piece of the graph. We graphed a piece of the absolute value that was less than 1. Not the whole thing, just a piece. Okay, let's do another one. Go ahead and copy this down. So now we have a piece of a parabola and we have a piece of a linear. So I'll give you a minute to copy it down and then we'll make our charts. Okay, so let's go ahead and get started. So now let's pay attention now. Let me make sure I'm awake right here. So let's start with that. Let's make our chart. And we want to pick numbers. You got to start it at 2. Now, what does that inequality say? Does that say x has to be less than or equal to 2 or greater than and equal to 2? Less than. So let's pick numbers that are less than 2. So we can go with, what numbers? Give me some numbers, whatever you want to. 1 and 0. Okay, let's make it simple. All right, so go ahead and clear out some space. All right, so go ahead and let's type these in. So you have 2 minus 2 squared, 1 minus 2 squared, 0 minus 2 squared. Go ahead and get your y values. So 2 minus 2 is 0, and 0 squared is 0. 1 minus 2 is negative 1, but negative 1 squared is positive 1. 0 minus 2 is negative 2, but negative 2 squared is positive 4. Now, look here, because this tells you how that first point should be graphed. So is this first point open or closed? Closed. So we're going to put a closed circle at 0, 2. And then we're going to put a, everything else, at 2, 0. Put a closed point at 2, 0, which is on the x-axis. Okay. And then we're going to put a point at 1, 1. And then we have a point at 0, 4. So again, this is just a piece of the parabola. And if you feel like you need to put more than 3 points, you put as many points as you need to understand the graph. So like, for example, if this was the test and you did something like this, then you don't understand what a parabola looks like. A parabola doesn't do that. So if you need to put more than 3 points, then you put as many as you need. A parabola, you should know that a quadratic looks like that. So that is a part of understanding the functions and how they behave. All right, so now let's do our second piece. Let's look at this one here. We're going to make our T-chart. So again, we're going to start it at 2. And we're going to pick numbers greater than 2. Now, I'm noticing that I have to multiply by a half, so I'm going to pick even numbers, so I don't have to graph a decimal. So I'm going to pick numbers that if I take half of it, it'll still be whole. So I'm going to use 2, 4, and 6. All right, go ahead and use your calculators to figure out what you get. Now, you can do 2, 3, and 4, but 3 is going to be a decimal. and that's okay. I just don't want to deal with a decimal on a Monday morning. So I'm going to use 2, 4, and 6. So go ahead and take 1/2 of 2, and then you're going to add 1. And then you do 1/2 of 4, add 1. And then you do 1/2 of 6, add 1. So go ahead and do that. Get your 3 y values. Yep, okay. Half of 2 is 1. 1 plus 1 is 2. Half of 4 is 2. 2 plus 1 is 3. Half of 6 is 3. And 3 plus 1 is 4. So who had that for their numbers? Now this first number, though, because this second graph does not own 2. So this first point at 2, 2 is open. Everything else is closed. It's just the beginning of that function is open. So we're going to put an open circle at 2, 2. So that's open. And then everything else is closed. And this only goes this direction. And that would be your graph. Set my clock so I can see what time it is. Okay. Right. Now you can have, just like when we were talking about the discontinuities last week, you can have 2 open circles. So that's possible. But you can never have 2 closed circles, because 2 closed circles means it's not a function. So it is possible that these could both of these could not be equal. But they both can't be equal. Okay, so let's do one more, and this one has 3. So this is the piece of the domain. This part in yellow that I have highlighted in yellow, that's just telling me the X values that I have to use on the table.